So we've talked about adding, subtracting, and multiplying polynomials. It stands to reason, it's very natural to ask ourselves, can we divide polynomials? And this concept actually is something that we should have done in elementary school in 5th or 6th grade. Let's go back to 5th grade for a second here and ask yourself, how would you divide, say, I don't know, 7,341 by the number 4, right? Well, as we should have done in middle school or elementary school, what you divide by goes on the outside of a bracket. What you divide into goes on the inside. Now, we don't ask yourself how many times does 4 go into 7,341. We take it bit by bit. We first ask ourselves, how many times does 4 go into a 7? And of course, the answer is 1. We put a number 1 here. Then we say, okay, 1 times 4 gives us what? The answer is 4. And we put the answer on, inside the bracket. And then we subtract. 7 minus 4 is 3. And then the last step we bring down. This process is what is known as the division algorithm, and it's something that we should have learned in elementary school or middle school. And then to long divide, you just rinse and repeat this process. You ask yourself, how many times does 4 go into 33? So you go ahead and do that division. 33 divided by 4 is at most 8 times. 8 times 4 is 32. You subtract, and then you bring down. 4 goes into 14 3 times. 3 times 4 is 12. You subtract 2. You bring down. 4 goes into 25 times. You multiply, subtract. Now, at this point here, we probably learned how to use a decimal, add a 0, and continue the process. But we're actually going to stop at at elementary school. Now, at elementary school, they probably said, hey, just make a remainder of 1. Well, that is true. 7,341 is 1,835 with the remainder of 1. But the way that we're going to write this answer here is thus. 7,341 divided by 4 is 1,835 plus that remainder of 1 tells us we have 1 out of 4 parts. This is our answer. So that's what is known as the division algorithm. It is a process that allows us to long divide integers, regular numbers. First step is to divide. Second step is to multiply. Third step is to subtract. Fourth step is to bring down. And then you just rinse and repeat this process. You work all the way to the bottom and then cycle back to the top. Well, not surprisingly, or maybe it's surprisingly, we can do the same logic. We can do the same thought process with polynomials. It doesn't really change when I substitute the numbers with variables. So that's sort of like the idea here. You can use the same process with polynomials. However, there's a caveat. Every power or exponent needs to be accounted for. If you count down from the degree, and remember, in math, the word degree means the highest exponent. So if you count down from the highest exponent and something is missing, use a 0 placeholder. And I'll do an example that showcases this. Right? But let's see truly how this division algorithm can work with complicated looking polynomials. Suppose I ask you to divide this function, say 3x to the 4th minus 5x cubed plus 4x squared minus 6 by x squared minus 3x plus 5. So the first thing I'm doing is I'm going to set up my bracket. So clearly I'm dividing by x squared minus 3x plus 5, so that goes on the outside, and I'm dividing into f of x. Now notice that the degree of f of x is 4, it's the fourth power. So as I count downwards, every single term needs to be accounted for. Oh, by the way, I'm going to change the problem a little bit. Instead of a 4x squared, let's just make it a 4x. Every single term needs to be accounted for. So it's 3x to the 4 minus 5x cubed. Notice the very next thing, if I'm counting down, should be an x squared. But I don't have any x squares. So I'm going to add a plus 0x squares just as a placeholder. So this is what I mean by a placeholder. The original problem was missing an x squared, so we'll fill a 0x squared in its place. So that's the setup. Now what do we do? Now remember how when we did with regular numbers, we didn't go 4 into the whole problem. No. When we divided, we only look at 4 with the 7. And that's sort of the idea. When you divide polynomials, you don't look at the whole problem. Rather, there we go. Rather, you only look at the first bits, right? So I ask myself, okay, x squared minus 3x to the 4. What's 3x to the 4th divided by x squared? Now, if you can't do that in your head, just take out some insurance. Do scratch work. What's 3x to the 4th divided by x squared, right? Hopefully you can see this is a properties of exponents problems. When you divide like basis, you subtract the exponent. So 4 minus 2 is 2. Now, just like with regular numbers, once we take this answer, we have to multiply it by our divisor. So again, if you don't know how to do it in your head, just take out some insurance and write it down on scratch work. Hey, this is multiplying polynomials. We just did this. So that's 3x to the 4 minus 9x cubes plus 15x squared. So I'll go ahead and put that here. And then the next step is subtract. Hey, it's subtracting polynomials. We just did that. Here's my suggestion to you when it comes to subtracting. I always distribute the negative in. To distribute the negative, all you have to do is change this to a plus and then flip all of the symbols. And then now you can go ahead and combine. So for the x to the 4th, 3 minus 3 is gone. For the x cubes, negative 5 plus 9 is a positive 4. For the x squares, 0 minus 15 is a minus 15. And just like with regular numbers, the last step is to bring down. What we wrote there is one complete cycle. And then you just rinse and repeat. So do it all over again. Look at the first bits and divide them. And again, if you can't do that in your head, just go ahead and use scratch paper. So I can see that 4x cubed divided by x squared is 4x. It's a positive 4x, so I'll put a plus, and then you multiply. Take this 4x and multiply it by the divisor. Again, if you can't do it in your head, just use scratch paper. And then distribute. So that's 4x cubed minus 12x squared plus 20x's. I'll go ahead and put him down here. You go ahead and subtract. But instead of subtracting, I'm going to flip all the signs. This becomes a plus, this becomes a minus, this becomes a plus, that becomes a minus. Let's work with the x cubes. The 4's will cancel. Let's work with the x squares. Negative 15 plus 12 is a negative 3x squares. Let's work with the x's. Positive 4 with a negative 20 is a negative 16x. And then the last step is to bring down. We got one more step to go. We start over, divide, and again, you only divide the first pieces. So, negative 3x squared divided by x squared, we can clearly see the x squareds cancel, so that leaves us with a negative 3. So I'm going to write a minus 3 up here, and then you just multiply. Take the negative 3 and multiply it with the whole divisor. Negative 3 times x squared minus 3x plus 5. You distribute. Negative 3x squared plus 9x's minus 15, and we'll go ahead and write it underneath here. And then the last step is to subtract. And again, instead of subtracting, I'll go ahead and just flip all the signs. So this becomes a plus, this becomes a plus, that becomes a minus, this becomes a plus. And then you just go and combine. The x squares, the negative 3 with the positive 3 cancels. The x's, and the negative 16 with the negative 9 is a negative 25x's. And then the constants, negative 6 with a plus 15 is a plus 9. Notice how there's nothing left to bring down. That is a signal that things are done. Another signal that you are finished is notice that this exponent is smaller than that exponent. So this right here is our remainder. So what is our answer? Don't just leave this as your final answer. You actually have to write something down. Your answer is up here. This is your quotient plus your remainder. So let's go ahead and write them down. So the answer is up here. 3x squared plus 4x's minus 3. And how we deal with the remainders is we always add the remainder over what we divided by. X squared minus 3x plus 5. That is our answer. So I hope we can see that it's just like regular division, except you have to deal with variables. Let's just go ahead and include one more example in this video because I just don't want to leave you with one. If you think you have the hang of it, feel free to fast forward through this example, but let's go ahead and work another example together. So let's go ahead and divide. Now, I could write it out in word form, divide, or I could give you in fractional form. So be comfortable with either way. So instructions: find 5x to the 4 minus 2x cubed minus 7x squared minus 39 all over x squared plus 2x minus 4. So let's go ahead and set it up. I'm dividing by x squared plus 2x minus 4, so that goes on the outside. And I'm dividing into 5x to the 4 minus 2x cubed minus 7x squares. Wait a minute, I'm missing my regular x. So I'll put a plus 0x and then minus 39. So let's go ahead and divide. I'll divide the first pieces together. So I'm not going to show my scratch work. So 5x to the 4th divided by x squared is 5x cubed. Multiply 5x cubed times all of this stuff here is going to be 5x squared, excuse me. 5x squared divided by all of this stuff here is going to give me 5x to the 4 plus 10x cubed minus 20x squares. I'm going to subtract, but instead of subtracting, I'm just going to flip all the signs. So this becomes a plus, that becomes a minus, that becomes a minus, that becomes a plus. The x to the 4th are canceled. I have negative 12x cubed, a positive 13x squares. Bring down the 0. Then repeat, take the negative 12x cubed divided by x squares. So that's going to give you a minus 12x's. Multiply, negative 12x cubed minus 24x squares plus 24x's. Subtract, but instead of subtracting, just flip all the signs. This becomes a plus, this becomes a plus, that becomes a minus. The x cubes are gone. The x squares gives me a positive 37x squares. The x's gives me a minus, what's that? Oh, actually, sorry. 12 times 4 is a 48. I can't multiply, so that'd be a minus 48x. And then bring down the minus 39. One more to go. This guy divided by that guy gives me a positive 37. I might actually have to break out a calculator for this. Multiply 37x squares plus 60 74x's minus 37 and 4 makes a 148, I think. And then go ahead and subtract. But instead of subtracting, I'm going to flip all the signs. The x squares are gone. The x's is a negative 122x's. And then the constants is a positive 109. So there's nothing left to bring down, so I know I'm done. So there's our answer. Here's our quotient, and then there's our remainder. We just have to write it down properly. So our answer is the quotient 5x squared minus 12x's plus 37. plus the remainder of 122x plus 109 over our divisor, x squared plus 2x minus 4. So hopefully, this seems like a lot of work, and I'll admit it is, but it's just the regular division algorithm. It's stuff we've been doing in since grade school. Now, for every long process, there has to be a shortcut. Indeed, there is a shortcut, though. If you are dividing by a monic linear factor or term, and monic linear factor is just a fancy way of saying x plus a number or x minus a number, right? So if you're dividing by a simple x plus or minus a number, then you can use synthetic division. Remember that synthetic substitution we did last week? Well, that is a process of dividing out monic linear terms. So we can use the same process, that L bracket process, to speed up this division thing, assuming we're dividing by monic linear terms. Let's do an example here. Suppose I ask you to divide x to the 4 plus 4x cubed plus 16x's minus 35 by x plus 5. So let's set up the L bracket instead. And the reason why I can do the L bracket is because I'm asking to divide by a simple x plus or minus a simple number. If this wasn't a simple x, if this was an x squared or a 2x, we would not be able to do this. But since it's a simple x, we can go ahead and do synthetic division. As before, we'll put the coefficients of our problems in the top row. So we have a 1, a 4, a 16, so on and so forth. So we have a 1, a 4, but wait a minute. Remember that these guys stands for the x's, x to the 4th, x cubed. Next should be an x squared, x and then a constant. I don't have an x squared, so just as before, I got to put a 0 as a placeholder. Now remember when we did synthetic substitution, we were always putting a regular number out here. I don't give you a number, I give you a factor. So that's something super duper important here. Only numbers go here. Well, the question is, what number do we put? You always put the 0 or the roots of your divisor. Basically, you always put the answer of whatever it is you're dividing by. So since I'm dividing by x plus 5, I'm going to set them equal to 0 and solve. So that gives me a root of negative 5. So you got to put a negative 5 here, right? So that's the only extra caveat that you have to be careful of. You can only synthetically divide by numbers, not factors. So I'm going to assume we're okay with synthetic division. That was last week's stuff. So if you're still iffy with synthetic division, review last week. But synthetic division only has 2 steps. Add down, so that's a 1. Multiply by the outside number. 1 times negative 5 is negative 5. Add down, that's negative 1. Multiply, positive 5. Add down, that's a 5. Multiply, negative 25. Add down, that's a negative 9. Multiply, that's a 45. Add down, and it's 10. And I always like to bracket it off the last number. That's great. We're done. We divided. But of course, that's not our answer. That's not what we're going to write down. We have to write down our answer properly. So how does synthetic division work? Synthetic division will always reduce your degree by 1. So notice how our original problem started with x to the 4. This number will start with one exponent less, x cubed, and then you just go downwards from there. This is x squared, x constant. What about this extra number? That's your remainder. So our answer is 1x cubed minus 1x squares plus 5x's minus 9 plus the remainder over what we divided by. And we did not divide by negative 5. That was a 0 or a root. We divided by x plus 5. So you can see here how synthetic division will make quick work out of division problem if we're dividing by a monic linear factor. Let's just do one more example just so you can have more than one to look at. Again, if you feel like you got this, feel free to skip and fast forward. Let's do one last example. Let's say I wanted to divide 2x cubed plus x squared minus 8x plus 5. This would also be a good time to pause the video and try it yourself and see if you truly get it. You know, sort of like test yourself. Here we go. So I'm going to set up my L bracket. 2, 1, negative 8, 5. Nothing was missing, so I didn't have to do any zeros. I'm dividing by x plus 3, so his 0, or the roots, would be negative 3. Bring down the 2, multiply, add, negative 5, multiply, 15, add, that is a negative 7, actually positive 7, multiply, negative 21, this would be a negative 16. Our original problem will start with x cubes, so this guy here will start with x squared. So there's our answer. 2x squares minus 5x's plus 7 plus the remainder of negative 16 over what we divided by, x plus 13. This is a perfectly fine answer, and I'll give you full credits for it. Just note that in the practice and in the future, the answer key may not put it like this. Whenever your remainder is negative, we typically like to change the plus to a minus. It's just an aesthetics thing. It is 100% the same answer, but for mathematicians, this looks a lot prettier and nicer. But again, I will give you full credit for this. Now, why am I talking about synthetic division? Why do we like to divide polynomials? I mean, it looks like a headache. I don't want to do this. Why would anyone want to do this? Well, the idea is that dividing will always make your problem smaller, and that's the whole point of solving equations, right? When the problems are smaller, it's easier to work with. So if I ask you to solve an equation and you already know a factor or you already know a zero, just divide it out to make life simple for yourself. For example, suppose I ask you to solve f of x equals x cubed plus 6x squared plus 11x plus 6, knowing that x plus 3 is a factor. Now, this would be a hard problem to solve, right? Because we have 4 pieces, we would typically use factor by grouping, but guess what? Factor by grouping will not work here. If you were to try it, take my word for it, if you were to try it, it wouldn't work, so this would be hard. But aha, the problem helped us. The problem gave us a little hint. I know x plus 3 is a factor. Because I know x plus 3 is a factor, we can make the problem smaller by simply dividing it out. Of course, I could use long division, but since this is a monic linear term, let's go ahead and just use synthetic division. So I'm going to synthetically divide this guy by that guy. So we have a 1, 6, 11, 6, and a negative 3. So let's go ahead and do this. 1, negative 3, 3, negative 9, 2, negative 6, 0. Notice how we got a remainder of 0. That shouldn't be surprising because I told you x plus 3 is a factor. And by definition, a factor is something that divides evenly and nicely. Well, remember that these guys start with x cubes, so this starts with x squares. And what is it that I'm asking you to do? I'm asking you to solve. A lot of people did not do this correctly on the quiz. They just, when I said solve, they just left in factored form. But solving just means you take the problem and set it equal to 0. And now you can go ahead and solve it however you will, right? Solve it by factoring if possible, because it's a regular quadratic. And if it's not factorable, you can use the quadratic formula. And I picked this example so he was factorable, x and x, plus 2 plus 1. So we get x equals negative 2, x equals negative 1. So we have 2 answers. But as someone mentioned last week, hey, the exponent was 3. And whatever the exponent is should be the number of answers that we got. Where is our missing third answer? Well, our missing third answer is what they gave you. Remember, they told you x plus 3 is a factor. So this negative 3 must also be an answer as well. So don't forget to include x equals negative 3 as your part of your answer. So there are our 3 answers. So that's it. That's how we divide polynomials, and that's how we can use dividing polynomials to help us solve equations. Let's just do one last example because I like doing two examples. And I'm going to write the instructions in a different way because they could ask you it in one way or the other. I want you to be comfortable to understand that it's the same process. So suppose I told you that 1, 0 of f of x equals x cubed minus 2x squared minus 23x plus 60 is x equals 3. What are the other zeros of f? In this case here, what information did I give you? I didn't give you a factor, but I gave you a zero or a root. So how does that change is when I do synthetic division, 1, negative 2, negative 23, 60, this is the number that I'm going to use. Because again, this guy is a number, whereas this guy was a factor. So when it comes to synthetic division, you can't use factors. You have to use numbers. You have to use zeros or roots. In this particular case, let me erase this. In this particular case, they did give me a zero. They did give me a root. So I'll just go ahead and use that number as is. So that's the only little extra thing I wanted to make notes. But let's go ahead and see the solution to this example. Bring down, multiply, add, multiply, add, multiply, add, and we get a zero as a remainder. This is sort of a nice self-check. If I tell you something is a zero or a factor and you do not get a remainder of zero, you probably did something wrong. So the original problem started with x cubes, so this is an x squared. So that means I need, and the instruction said solve, find the zeros, that means solve. So that means I need to solve x squared plus x minus 20 equals 0, and then you solve it however you will. Solve it by factoring, quadratic formula, completing the square, etc., etc., etc. This guy is factorable, x and x. So what is that? Say positive 5 minus 4. So x equals negative 5, x equals 4, and don't forget the original 3 that they gave you. Those are our 3 answers. There you go. That is it. That is 5.5.